So here we've got a system of 3 equations which we're going to try and solve using Gauss Jordan Elimination. So what Gauss Jordan Elimination requires is taking our system of equations. Now it doesn't have to be 3 lots of 3, it could be 2 of 2, it could be 4 lots of equations with 4 variables and so on. So what we do is we set up these coefficients of these 3 equations into some sort of matrix. So -5, 2 and 4 is my first line of coefficients. Then I've got 2, -8, 2. And then I've got 4, 2, -5. And then just to keep it in this format, I multiply this 3 by 3 matrix by a 3 by 1 matrix, x, y, z. So that keeps those. And then I set it to the results, which is all zeros. Okay, so that's our setup to get our result. So now what I want to do is I'll take this first matrix here and I want to try and reduce a lot of these ones on this bottom triangle here into zeros. And then on the top right triangle, I want to get some 1s and some zeros, so as many zeros as I can. But 1s is where then I'm going to find what my values of x, y and z are. So first of all, let's do the setup and write down this matrix. So I've got -5, 2, 4, 2, -8, 2, 4, 2 and -5. And first of all, to try and get a 0 or 1 in some of these, I can get that into a 1 straight away by multiplying row 1 by -1/5. That will reduce that to a 1. So let's label them all up. So row 2, row 3. And what I'll do is do row 1 now becomes -1/5 of row 1. So let's do the calculations for that. So that then becomes 1. -1/5 times 2 is -2/5. And 4 times -1/5 is -4/5. And then the rest can stay as they are. And I've got 4, 2, -5. Okay, right. Now let's have a look at row 2. Is there anything I can do to that? Well, as I've got a 1 here, and I want to get some zeros in here, if I take row 2 and subtract 2 row 1s, that will also work for that one. So row 2 now becomes row 2 minus 2 row 1s. So let's do that. Now the bottom 2 rows aren't going to change. So the top and bottom rows aren't going to change. So I can write them in as they are. 4, 2, -5. And then let's fill in this one. So 2 minus 2 row 1s. So 2 minus 2 gives me 0. -8 minus 2 lots of 2/5. Let's write this one down so we don't make a mistake. So -8. So -8 minus 2 lots of -2/5. That becomes -8 plus 4/5. Well, -8 is -40/5. So that gives us then -36/5. So that's that. And then this one, I've got a 2. So I now want 2 minus 2 lots and use the corresponding value in the column here, -4/5. So now 2 plus 8/5. So 2 is 10/5. So that now becomes 18/5. So that's that taken care of. So that's all good. So now we can do something similar to get a 0 here and do row 3 minus 4 row 1s. So row 3 becomes row 3 minus 4 lots of row 1. So let's write the top 2 rows in because they're not going to change. And 0 minus 36/5 and 18/5. Okay, row 3. So I've got 4 minus 4 times 1. Obviously that becomes 0. That's what we wanted. So that's it. We've got some zeros coming up now. That's good. Now second one, I've got 2 minus 4 times -2/5. So that becomes 2 plus 8 over 5, which is the same, very similar to this one here. So 2 plus 8 over 5, that's going to give me 18 over 5. That's that. And then the last one, I've got a minus 5, and I want to subtract 4 times minus 4/5. So now I've got minus 5 plus 16 over 5. So minus 5 is minus 25 over 5. So that then becomes minus 9 over 5. Okay. So that's what we've done now. So we've got some zeros there so far. Okay, let's take these bits off the board. Okay, right. So we've got some zeros there. That's great news. Now we want to get some zeros here if we can. Now, I can't get a 0 there, but I could get a 1. So if I multiply that by the reciprocal of it, that would then become a 1. So if I get row 2, right here, and what I can do is then multiply row 2 by minus 5 over 36. So row 2 times minus 5 over 36. So let's put row 1 back in. 1 minus 2/5 and minus 4/5, and the bottom won't change. 0, 18 over 5 minus 9 over 5. Okay, well 0 times anything is going to be 0, so that's going to stay. We don't want to change that. So key here is not to add anything if we can help it. Minus 36 over 5 times minus 5 over 36, that's going to give me 1 as required. And now 18 over 5, let's go careful here. So I've got 18 over 5 times minus 5 over 36. Okay, well that's going to cancel and give me a minus 1. And then that's going to cancel and give me a 2. And it's a half actually, minus 1/2. Okay, let's take this bit off the board. Okay, so I've got a 1 here and a minus 2/5 here. If I was to multiply this row by 2/5, I'd end up with plus 2/5 and a 0. Then add it to this one, I'll get that into a 0 there. So let's write that one up. So row 1, that becomes row 1 plus 2/5 of row 2. So let's see if we can get that one in there. So row 2 is not going to change, just keep that one in. And row 3 the same, 0, 18 over 5 minus 9 over 5. Right, let's do this top row. So row 1 plus 2/5 of row 2. So 1 plus 2/5 of row 2, that's going to stay as 1, that's what we want. So this one here, I've got minus 2/5 plus 2/5 of row 2. So 2/5 of 1, that's just going to be 2/5. So minus 2/5 plus 2/5 gives me a 0. So that's great news. Now let's go with this one here. So we've got row 1 becomes row 1, so that's minus 4/5 plus 2/5 of row 2, which is minus 1/2. So now I've got minus 4/5 minus 2 over 10. 2 over 10 is a fifth, so minus 4/5 minus 2/10 becomes minus 1. So great news. So I've got a 1 there as well. Okay, let's take these calculations off the board. Okay, so now as we've got 0, 0, and we've got 1 and 18/5, what about if I multiply row 2 by 5 over 18 and subtract it from row 3? Let's do that. So now row 3 becomes row 3 minus 18 over 5 times row 2. So let's see what we get there now. So the top row is not going to change. Okay, so row 3 is 0 minus 18/5 of row 2. Well, that's another 0. 0 minus 0 gives me 0. Okay, so that's that one. Now next one, got 1 and 18 over 5. So I've got 18 over 5 minus 18 over 5 times 1. So that is also going to give me 0. So now this is starting to look like a good matrix now for getting our results. Now the last one, I've got minus 1/2 and minus 9/5. So now I've got minus 9 over 5 minus 18 over 5 times minus 1/2. Okay, well, minus 18 over 5 times minus a half, that's then going to give me plus 18 over 10, which is plus 9 over 5. So that will also become 0. So they've got extra bonus here. So that's the result so far of our matrices so far, reducing down. So that there, I'm happy with that. I've got 2 unknowns and 2 unknowns with 3 variables. I can solve that. So let's take this off the board, keep this matrix and find our results. Okay, so that's our Gauss Jordan elimination of this matrix to try and help solve it. So now what we're going to do, we're going to put it back into this form and let's see what we can do from there. It should be a lot easier than when we first started with this. So now we get multiplying across using matrix multiplication rules. We've got 1x minus z. So x minus z, and that's going to be equal to 0. Second row, I've got y minus a half z. That also equals 0. So y minus a half z, that also equals 0. And here I've got all zeros, so I can eliminate that line. I don't need it. Okay, let's manipulate these a little bit. So x minus z equals 0. That means x equals z. So I've got x equals z. And then what about here? Y minus a half z equals 0. So I can say now that y equals a half of z. So if y equals a half of z, that means 2y equals z. So if 2y equals z, I can put x equals 2y. Okay, so what can I do from there? Let's put them in there in our x, y and z for our matrices. So if I put everything in terms of z, I've got x represented in z, y represented in z, and z is obviously itself. So let's do that. So z will be itself, x is also z, and 2y equals z. So therefore y equals a half z, so I can just put half z in there. So multiplying through by 2, so if I multiply that by 2, that becomes 2z, so let's keep that different to the z, and then 2z. Okay, right, let's just imagine z equals 1, let's plug that in there, so let z equal 1. So now my matrix would now be 2, 1, 2. So now I've got 2, 1, 2. So therefore what I can do now is just put in the value of any variable k in terms of k. So k is in real numbers. I can now transfer this as k times 2, a k and 2k. So if I plug those values into these equations, they will give me solutions. So 2 could be 1 of the solutions, 2 for x, 1 for y, 2 for z. I could plug in 6 for x, 3 for y, and 6 for z. So let's try that. So let k equal 3. So therefore I've got 6 for x, that's minus 5 times 6 is minus 30. 2 y's, while k is 3, so that's plus 2 times 3, which is plus 6. And then plus 4 times 6, which is 24. And hey presto, that equals 0. So for this one, I'm going to use 6 for x. So if x is 6, I've got 12. If x is 6, then y is 3, so that's minus 24. And again, z would be 6. So therefore I would have to add 12 again. So that would then equal 0. That's good. And let's try this one here. Let x equal 6. That gives me 24. 2 times 3 is 6. So that's plus 6. And minus 5 times 6 is 30. So that's minus 30. That also equals 0. So this system of equations checks out. So I'm happy that will give me my answer. Okay.